Okay, so we are going to look at some examples of the use of macros over here. The first macro that you have already used and are actually probably quite comfortable with by now without even realizing that it was a macro is the hash include that we have out here, right? We will talk a little bit more about hash includes at a later point. They have a lot of interesting properties in themselves and can be used in order to create new text files naturally. But for now we are going to focus on the hash define, which is the other macro word that is commonly used, right? So as you can see over here, I have a few hash defines. One of them basically says hash define, there is a space and the letters pi, right? So I'm presumably sort of defining a value for pi, and it says 3.14159, okay. So this is great. It basically says that I have one place in my file where I have defined a parameter that I call pi. Now anywhere else in this code I can just use pi capital letters and it will take this text pi and replace it with the value 3.14159. Now it does it a little carefully. So for example, if you have the word pi for example somewhere inside a string or as part of the name of another variable, it is not likely to expand it out directly over there, right? So it's not going to sort of go and completely mess up your code. But on the other hand, a standalone word pi is going to get replaced with this number 3.14159, right? Similarly, this hash define hw is now going to be replaced by this complete string out here, hello world, including the quotation marks, right? So it's going to take the whole thing including the quotation marks and replace it directly out there, right? And finally you can see that there is yet another define which basically literally says hash define nothing. It does not say anything after that, okay. In other words, if I was to try and use this nothing parameter somewhere, it would get replaced by nothing. There wouldn't be anything at that point, okay. Now why would I do something like this? We will see that later when for example we look at the hash ifdef, which is used in order to check whether something has been defined or not. You don't care what the value is, you just want to check whether a variable whether a value has been defined or whether a parameter has been defined. So let's look at the use of these macros in some simple examples, right? So the most basic function that I have over here is literally a one-liner, which all that it does is it runs printf, it prints a string and it prints a floating point number after that, and as the arguments that to be printed out, I give this value hw for hello world and this value pi, right? And if I run this, you can see that sure enough it prints out exactly what I expect, right? The string, the %s over here has been replaced with hello world and the %g, the floating point number, has been replaced with the value that I defined for pi out here, okay. So far it looks nothing special, right? I mean, I could have done this by also declaring hw and pi. Hw could have been a char star, right, or a char array that I just initialize, or if I wanted I could have made it a const char array, right, if I wanted to make sure that people are not allowed to change it later. And similarly I could have used a const double or a const float or even just a float, right, in order to define pi, okay. And yes, that is absolutely correct, at least at this point over here, right. So the use of macros comes about more when you get to other parts of your definitions. In particular, what happens is that you sometimes do not necessarily want to create a new variable, because when I declare a double pi, right, or a float pi somewhere, it actually creates a particular memory location where that value is stored, puts that number over there, and everywhere that I use the value pi, it actually becomes a reference to that memory location, which means that at any point in the code where I am using it, I actually need to load a data from the memory location, put it in there and then perform my computation. In most cases that is not very problematic, right, it's perfectly fine to do so. But this is even simpler because literally after the compilation phase, pi doesn't exist anymore in your code. There is no variable called pi, there is no memory location corresponding to pi, it has literally been replaced with that number. and there is no trace of the fact that it was called pi before we wrote the code. Alright. Now, the second example is related to this line 5, which basically just does a hash define nothing. It actually allows you to do something like, I can have a piece of code that says hash if def nothing, printf nothing was defined, hash else it will print nothing was not defined, right. Now, let us first of all run this, right, and what you can see is that it basically says nothing was defined, right. In other words, it has taken this code, this part of the code, right. Now, interestingly, I can do two things. I could either comment this out and run it, right, at which point it says nothing was not defined, so clearly it has taken this branch of the code, or I can do something else, which is I first define it and then I go ahead and undefine it. And the undef achieves exactly the same purpose as not defining it in the first place, right. It basically allows me to replace the code. Now, the interesting thing and what you need to keep in mind over here is, this is an if condition, but this if condition was evaluated at compile time, which means that literally this printf nothing was defined does not even exist in the compiled code that is output from this program. The compiler, the first thing it does is basically it eliminates this, takes this out of the picture, says that this no longer exists in my code, and then it proceeds to compile only this line over here. Now, why would you do something of this sort? It's actually a fairly common thing to want to do something like this. In particular, these are what are called flags, right. So, I could define a particular flag that turns on or off certain kinds of behavior in my program, right. And the kind of behavior that I might be looking at might be something like, if I am running on a little endian architecture, then I need to process my numbers in a certain way, whereas if it is a big endian architecture, do it in another way, right. Now, that is a very simple kind of scenario. I know that when I am compiling my program, I am compiling either for little endian or for big endian. I cannot compile a program for both at the same time, right, unless there are some runtime libraries that handle it and so on, right, but that is not the typical scenario. We are more interested in how a particular architecture handles numbers and just go according to that. So, if I had one of these hash defines, right, and I set the flag correspondingly, this is little endian or this is big endian. Let us say that I am compiling on an Intel architecture, I set the little endian flag and that is it. All the code corresponding to big endian is just gone. It no longer even figures in the compilation process. It actually reduces the amount of code that needs to be compiled. The compilation runs faster. The final output executable is also more compact and efficient, right. By just changing that flag to big endian, I can now compile it on something like the ARM processor, right, and it would do the right thing straight away, right. In fact, more likely than setting little endian or big endian is that you would probably have a hash define somewhere that gives something related to your CPU architecture, right, and you would probably do a check that says if the CPU architecture matches something like this, then do something, okay. So, this hash if def is one way of doing it. You could also have written it as if defined nothing, right, and that would essentially give us exactly the same behavior. So, hash if space defined nothing and hash if def nothing have exactly the same behavior, right. The interesting thing about this if space defined is that you can also invert it by putting a not out there. So, if not defined nothing, right, and it basically inverts what ends up happening, as we can see by running this, right. So, nothing was not defined. It basically checked whether nothing was defined. Yes, it is actually defined over here, but it then inverts that and decides that it should actually go and take the else condition, which is why nothing was not defined gets printed out here, okay. Now, once again, just putting these things in for the sake of putting them in is probably a bad idea, but there are very specific scenarios where you will find that they are actually very useful. So now let us look at how macros can be used, and what I mean by macro in this instance is a macro that takes an argument, right, as an input. So the macro that I am defining here is on line 19, and it basically says define SQR of x, which is basically square of x, right, and I then just give a space and write x space star x, right. I originally wrote this as x space star space x because I would like to have it that way, but for whatever reason the replit auto formatter, which formats your code automatically when you save the file, decides that that space should not be there, right. So just ignore it for now. By the way, the formatting is also a very useful thing, so it's probably a good idea to get used to the replit formatter or some other kind of formatter in general, because it helps to keep your code relatively clean and understandable, right. So do not underestimate the usefulness of that, especially when you are looking for someone else to look at your code and give comments on it. It's always good to have it very well formatted. Alright, so we have defined a macro, right, and it looks like it takes one argument. That's great. I basically have x out here and I'm going to call it as x into x, okay. So what happens is, if I give this printf statement that is there on line 20, what I expect to see is that it will actually compute the square of 7 and put that value in there. Let's check, and sure enough it printed out the value 49, which is 7 squared. So far so good, it seems to be working fine, right. So now let's just go forward and I'm going to replace it with something similar, right. I just want it now to compute square of 2 plus 4, right. I know that 2 plus 4 is 6, but I'm lazy, I'm just going to write it out over there. And if I write what's the square of 2 plus 4, of course I expect to see the answer 36, instead what I see is 14, right. What happened here, right. So if we think about it, what has actually happened is that this line literally got replaced by SQR of 2 plus 4, basically got replaced by 2 plus 4 star, or rather there were no spaces there, right, because I have it exactly the way it is written, 2 plus 4 star 2 plus 4, right. Remember this, every single character that I have, the 2 plus 4 that I have written over here, is exactly the argument that I gave to the macro, right. If I had a space before the plus over here, I need to put a space before the plus over here and a space before the plus over here. I did not have a space after the star, which is why I immediately put in the 2 immediately after the star, right. This is important because that is telling you that's exactly how macro expansion works, right. It is not trying to evaluate any of your parameters, it's not trying to be clever, it's not trying to find out the type of the values that you are putting in there. This is just text expansion. It's taking the ASCII characters or whatever characters you have in your code and replacing them with what you expect it to be. So what has happened is, when I gave square of 2 plus 4, right, it basically went ahead and did 2 plus 4 star 2 plus 4. Now let's evaluate this, right. Star has a higher precedence of operation, meaning that if I write out the code 2 plus 3 into 5, the 3 into 5 is computed first and the 2 plus is computed after I have computed 3 into 5. So 2 plus 3 into 5 would actually get evaluated as 3 into 5, 15, plus 2, 17 is the result, and not as 2 plus 3, 5 into 5, 25. Okay. And this is just to do with how precedence of operations is defined, right. Now the reason why it is defined in that way is that is in some sense naturally how we think about how to write numbers, right. But of course there can be scenarios where, you know, at the end of the day it's a convention, okay. Now what has happened in this particular case is, when the macro got expanded, it wrote out this code as 2 plus 4 star 2 plus 4. So how does it get evaluated? First I take 4 into 2, which is 8, and then I do this 2 plus 8, which is 10, and 10 plus 4, which is 14, which is the result that I got out here, right. Why did this happen? Because this star operation had a higher precedence than the plus operation that I actually put into the macro, right, into the argument of the macro. So in other words, this plus operation that I have in the argument of the macro binds with lower precedence, as we say, than the star operation, which is the multiplication. So the star operation, the multiplication gets done first and then the additions, right. Of course, the order of the additions is also sort of fixed, right. It is a known way of doing it. The way that the compiler goes about creating the evaluation tree for this is a fixed algorithm. There is nothing sort of unknown about it, but the bottom line is that the star has a higher precedence and you end up getting the wrong answer. So how do we fix this, right? If you might be familiar with this term, the BODMAS, right, as I sometimes talked about in arithmetic in school, right, bracket, open, division, multiplication, addition, subtraction, which basically sort of gives you the order in which you need to consider the importance of different operations, right. And what that tells you is division has a higher precedence than multiplication, multiplication has a higher precedence than addition, addition has a higher precedence than subtraction, which means that if there is some particular piece of arithmetic that could have been interpreted in two different ways, you use that precedence description in order to figure out how it would actually get evaluated, which is why of course multiplication got evaluated before the addition. And that also gives us a clue about how to solve the problem, because the one thing that has the highest precedence of all is brackets. So if I put in brackets over here, right, if I was to do this, I can be sure that the answer would be correct. So I could have solved that problem, in other words, by basically writing it this way, right. I could have put in the 2 plus 4 as part of my parameter out here, okay, and let's check. Sure enough, that worked, right. So now the 2 plus 4, effectively it got translated into this macro. The problem is this is just asking for trouble, right. I mean, it's almost certain that at some point in time I will forget to put the parenthesis over there. Can we solve this problem in the macro itself? The answer is yes, right. I could just have put parenthesis around the macro, right. So by doing this, effectively, in other words, so by putting the parenthesis around the argument to the macro itself, I have actually solved that problem, and this is what I get as a result, right. And by giving square of 2 plus 4, I find that yes, it gives me the correct answer, 36. Is the problem solved? Not entirely. Remember what we said about precedence. There is something that binds even more higher precedence than multiplication, which is of course division. So let us look at what happens if I have already solved part of the problem, right. I have put in the parenthesis around x and it looks like I have got this problem solved over here, okay. Let me take this in stages and say, okay, what happens if I do not have the parenthesis first and if I run this particular piece of code, right. And you can see that what I expect is that 2 plus 3 is 5, the square of 5 should be 25, so 20 divided by 25 should have given me the answer 0.8. And of course I am printing it with a %g over here, so yes, I do expect to see a 0.8 of a decimal value. Instead I see 19. So what happened? Let us look at the first expansion out here, which basically says I am going to get 20.0 slash 2 plus 3 star 2 plus 3, okay. Let me just get rid of these spaces over here so that I know that it is exactly the expansion that I expect. Now let us evaluate this. What happens is I end up getting 20 divided by 2. This is the highest precedence and gets evaluated first, okay. So that goes to 10 plus 3 star 2 plus 3, okay. So in other words, this statement has got transformed into this. Now what you can see is that the plus is still the lowest precedence, so the star is the one that is going to get evaluated next, and what I end up seeing is 10 plus 6 plus 3, which is why we end up with 19 as the result. Okay. So the whole thing happened because of the fact that we tried to do this, we wrote the macro without putting parentheses. Alright, we already know that part of this problem was because of the 2 plus 3 not having parentheses around it. Fine, let's solve that problem, right? Put in parentheses out here, put in parentheses out here, okay, run it. Now I get 20. Things didn't get better, they got worse. What happened? Now let's look at the second case, right? I have 20.0 slash, now I have brackets, right? So 2 plus 3 and star 2 plus 3. Right, this looks good. The problem is, of course, the brackets have the highest precedence, which means that let me write it out this way, 20.0 divided by 5 star 5. So far so good, except for the fact that division has the highest precedence. So 20 divided by 5 ends up being 4 star 5, which is 20. So once again we end up with the wrong answer. Okay, how do we solve it? More brackets, right? Put one more set of brackets around the entire term out here, and now finally when we run it, we find that the answer comes out as 0.8, which is what we would have liked to see. Okay, so what happened in the third case is that 20.0, I now put in two sets of brackets, 2 plus 3 star 2 plus 3, right? And this basically gets evaluated exactly the way that I would like. 20.0 divided by, the first expansion is of the innermost brackets, and it becomes 5 star 5, and this becomes 20.0 divided by 25, because the division also binds later than the brackets, and this gives us the answer that we want. Okay. By the way, you might have noticed that there are a lot of these pieces of text that keep popping up over here. This is partly Replit trying to be helpful with AI assistance. There should be a way of turning it off. I haven't done that yet. Please do keep that in mind and ignore it. This is not part of the code that I'm actually using out here. Okay. So what we have seen, in other words, is that by putting sufficient number of parentheses carefully, you should be able to get the correct value out of a macro that we have defined out here.